Okay, there is a proof. It's a very simple one. It's easy to understand. And it's one of the great classics. This one has been around for certainly thousands of years. Now, Pythagoras, or more likely one of his followers, developed this, a squared plus b squared equals c squared for a right triangle, probably without a lot of thought of application. That's kind of not where the Pythagoreans were. If you want some fun, go back and read about these people, weird folks. But they developed this. It's obviously true. It's been proven now. We saw a proof. There are others of this statement. Go back over here now. The rest of us can now use this result so that every time we see a right triangle, we can calculate something useful and practical about it. And that's how math works. People who think abstractly, the mathematicians, the puzzle solvers, find interesting mathematical relations. And they generally do it without thought of application. Some do, but most don't, as far as I can tell. They develop new mathematics or discover it. There's kind of a debate. I'm going to go with discover. So they discover new mathematics, and then the rest of us get to find some application for it. We care about this now. So if we think about this in those terms, let's think about maybe trying to calculate the stall speed of an airplane, all right? Something we care about very, very much. If you try to pull the airplane off the ground below its stall speed, it isn't going to fly. If you try to fly it below the stall speed, it's also not going to fly, and you might crash. So that's bad. Now ask a mathematician about that equation, and the mathematician will rightly say something like, well, that's a specific case of a more general class of functions. In fact, there's a field of study called functional analysis. And so that particular equation that describes stall speed is just a specific instance of a larger group that mathematicians study. And to actually calculate the result from that, well, that solution is a triviality. It's a number calculated from a specific instance of a larger class. So the mathematician is not going to care. We care. I absolutely need to know what the stall speed of the airplane is. And so that's more of that difference in ways of thinking. Now, we're going to be over here all the time. This is a very practical class on how to calculate. Now, if you're going to calculate, you're going to need some tool to do it with. That's MATLAB. As I said, MATLAB is maybe not universal, but it's very, very popular. It's very widespread, powerful, sophisticated, everything we need. Now, as we go through MATLAB and the mathematical topics of this class, I'm going to be reiterating a lot, right? And there's a reason. As human beings, we learn through repetition. Now think about when you were trying to learn how to read, okay? And how did that go? Teacher went, okay, A, B, C, D, E, F, G, blah, blah, X, Y, Z, and here's a dictionary. Done. Now you know how to read. Is that how that worked? That's not how that worked. You needed much repetition. Now you needed a lot more because you were really little. But human beings do learn through repetition, all of us. I'm going to go back to repeat ideas a lot. Now, if you're one of those fortunate few who doesn't need repetition, you can just fast forward through that part of it. But for the rest of us, I want to make sure we see ideas enough times to internalize them so they're there when we need them. And with that in mind, let's start MATLAB. We're going to dip our toes in the water here, and we're going to learn a little bit about what the screen looks like and how to make some plots. So I'm going to go down to my computer right here, and we're going to get started learning MATLAB.